right? So this is a sigma node, and we saw in the thumbnail probably look like this. This is a video explaining what summation notation is, or sigma notation, and how you can use it. So we have over here, this is a limit, almost basically. This is a limit, and this is basically saying how much your summation goes up to. That's how much it goes up to. This over here, that's summand. This is basically, think of it as a function. It's you're gonna put a number here, or any, say like any number or any variables you would want in here that you want to add up in a format. And over here is going to be an index. An index is basically, you set a variable, say here, let's say a variable n, and it's going to go for a variable n is going to equal to 1, 0, or whatever number you want. And this number that you want is going to be the number that you start your summation with. So if your summation starts with the number 3, you would say n equal to 3, and that would be your index. All right, so from here, let's set an example. We know that this is going to be our limit. Over here is going to be our summand. And over here is our index. So let's set our limit to, let's do this. Let's set our limit to 100. Awesome. Now we're going to set our summand to, let's set our summand to n. Or what you probably see a lot of the time, you would probably see k or I. So let's set our to I, and then our index is going to be, what we're going to start with is we're going to start from 0. I is equal to 0. So what is this saying? So we're going to start from 0, and we're going to add all the way to 100. So what this is going to look like is, an expanded version of this would look like, is this would be equal to 0. 1, 0 plus 1 plus 2 plus 3 all the way to 100. Now you would see these forms together. You would see this form over here, and you would also see this form over here going hand in hand. But you can see that this form looks a lot more cleaner, a lot more neater than all of this, right? Now, what would this be equal to? You'd put this into your calculator, and it would, result in a number. But another way you could do this is if you wanted to add the numbers from all the way from 1 to 100, is you would use, Frederick Gauss is known for this. Carl Gauss. He found out that to add from numbers from 0 or 1 to 100, all he had to do was, he saw a pattern. He saw 1 and 100 added up to 101. 99 and 2 added up to 101. 98 and 3 added to 101. 97 and 4 added to 101. Now, he saw this pattern all the way through till he reached 49 and 50. But he just immediately saw the pattern and decided, hey, this goes all the way around. So if you multiply that by 100, you'd be able to say 100 plus 1, right? 100 plus 1 times 100 over 2 would also equal the sum. And if you do this in your calculator, it would equal to all this, this would both equal to 5,050. Let's do another example. So imagine you have a summation with that wants to go all the way up to 198. Great. And then it's also asking you to, it also has an index of k equals 1 with a summand of 2n plus 1. It would just be, you know, it would just, if it was just k, it would go from 1 plus 2 plus 3 all the way to plus 197 plus 198. So it would just be a series, right? But from, since there's a variable like this, you're able to say that it would, since the index is 1, we would go from 2 times 1 plus 1 plus 2 times 2 plus 1, and then you would keep going. Sorry for the slanted handwriting. And it would always equal to an odd number all the way till the limit of 198, until, you know, keep going, dot dot dot, 2 times 197 plus 1 plus 2 times 198 plus 1. So that's how summation works. Let me give you another problem. So this is maybe something you've never seen before. This is what is something called a nested summation, where we have the limit as 6, an index of k equals 1, and a summand of a summation. Now, what is this basically saying? This is basically saying that j from the outer summation, the inner summation runs through the values of k. So what would that, and we have these the summand of the inner summation as 1. So when k is equal to 1, the value is 1. But when k is in the value of 2, j is still equal to 1. When k is equal to 2, then it's 1 plus 1. Got it? When k equals 3, j is still equal to 1. And the summand, it becomes 1 plus 1 plus 1, which equals to 3. This equals to 2. So this is basically saying through the values of k, j runs through the values of k, with the summand being added. So this would be 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is 21. If the summand was j, what would that mean? What would happen when the summand is j then K would run through all the J would run through all the values of K and add them. Well, so what does that look like? When K is equal to 1, that would mean J, the index, would equal to 1, and the value would be equal to 1. Now, we would add this, since this is a summation, we add them. This would equal to, when K is equal to 2, J equals to 1, this would equal to 1 plus 1, which is equal to 2. You might see a pattern after the third one. We would add it again. Alright, and then K would be equal to 3. J still equal to 1. And then it would be 1 plus 2 plus 3. Now this goes on through all the values of K. But what this really looks like, when you see what this really looks like, you see a repetition now. Instead of one value of K, we have multiple values of J. We have 1, 1, 1. So at the end, this would look like 1 plus 1 plus 1 plus 1 plus 1 plus 1, 6 times, because there's 6 values of K that J has to run through. 6 values of 1. We would also see 2 plus 2 plus 2 plus 2 plus 2. Now you see that there's only 5 values of 2, because J in the first one only goes up to 1, but only after the second summation it goes up to 2. So 2 would be 1 less time than 1. Then we have 3 plus 3 plus 3 plus 3. Now you see this again, it's 1 less, because 3 didn't show up in the first summation, didn't show up in the second summation, but only started to add up in the third summation. Same with value 4. Same with value 5. And now you see one value of 6. It's one value of 6 because only in the last summation, 6 showed up 1 time. And that was in the last summation. And all of this would be equal to 56.